In this problem, we're going to use conservation of momentum and work energy principle. And we're going to use the conservation of momentum to figure out the velocities after the explosion. And we're going to use the principle of work and energy to figure out the work done by friction and relate that to the distance that the boards travel after the explosion. So conservation of momentum tells us the initial momentum before the explosion should be equal to the final momentum after the explosion, and we can express the final momentum after the explosion as the mass of the small block times its velocity plus the mass of the big block times its velocity, and the minus sign is there because the blocks are traveling in the opposite way. This expression above can be solved to relate the velocity of the small block to the big block, and we can say the velocity of the small block is 3 times the velocity of the big block. Now, the friction force acting on the small block is going to be equal to, and I'm going to denote that by a small f, going to be equal to the coefficient of friction times the normal force acting on the small block. And the friction force on the big block is likewise equal to the coefficient of friction times the normal force acting on it. Now, the friction force times the distance is work done by friction force. And to make the block come to a full stop, that should be equal to the kinetic energy of the block after the collision. And I've written the expression down for the small block first. For the big block, it's very similar. It's going to be equal to its mass times its velocity squared. Now, all we have to do is that we have to relate the distances traveled by the small block, which I denote by small d, and the distance traveled by the big block to its velocities and everything else. We can write this down and say the friction force acting on the small block times its distance is equal to its kinetic energy. And the friction force acting on the larger block times the distance traveled by it is equal to its kinetic energy. Now we can solve these two expressions by dividing each side by each other, and this will tell us d small d divided by 3 big D is equal to 3, because the velocities will cancel, the masses will cancel, and the factors of 1/2 will cancel. Thus, we can say the distance traveled by the small block is 9 times the distance traveled by the large block.